welcome to ePart Trade Live. This is our first tech webinar. We plan several more in the future. This one is how to optimize ring seal to improve engine performance with Lake Speed Jr., Vice President of Sales and Marketing for Total Seal Piston Rings, and noted race engine builder, Jon Kaase. I'm John Kilroy. I'm Chief of Content and Audience Development for ePart Trade. I just want to go through a couple of quick housekeeping tips before we get on to the content. So just so you know, all webinar attendees will be on mute the entire time because we want to proceed without distractions or interruptions. We recommend switching to speaker view on Zoom. And we want to get your questions. So when I talked to Nick about this, he really wants to answer your specific questions. We have some very knowledgeable people in the room with us today, race engine builders. So the questions can be quite sophisticated. At the bottom of your Zoom screen, there's an option for chat. So you can open up chat, you can type in your question and send it along, and we'll have a record of your questions, and that's kind of what we'll use for this webinar. So we can take your questions right now. So while we're waiting, if you have a burning question that you came to this room for, just open up chat, send us a question, and we'll get to it later on. Unfortunately, if any of you are having trouble with Zoom, it's not quite perfect right this minute, we just won't be able to handle your technical issues, so we'll just do the best we can today. This webinar will be recorded. We want to share it with people in the future, so just be aware of that. And then for all of you attending live, you'll get an email with a link so that you can watch the video later or share it with people in the shop. And then for those of you not registered, we'll send you kind of a complimentary password. So you'll get an email with the link to the video, password, so you can get onto it with ease. All right? And then just a quick note on ePart Trade. For those of you who maybe haven't gone on and clicked around to find out what we're doing, it's a robust digital platform for sourcing products or suppliers in racing. You can use it 24/7 from wherever you are. You can shop the world because it's truly a global shopping experience. The internet has no borders. So this is a place to go and hang out online to figure out how to solve some of your issues, your technical issues in racing, and get the solutions really quickly. Get a bunch of options. There's no charge for buyers to use ePart Trade. I encourage you to register and click through it and find out what we're doing. New products every day, popular products every day, technical papers, technical videos, racing industry news. It's just a great place to hang out, start your morning with your morning cup of coffee. And then we've got 25,000 racing organizations as part of ePart Trade, suppliers around the world, racing businesses around the world, race teams around the world. We've essentially taken the global racing industry and put it all online for you. 25,000 racing organizations at your fingertips. It's only for sourcing products. It's not an e-commerce site, so we're not in competition with speed shops or race engine businesses or warehouse distributors or anybody like that. And our smart sourcing software is intended to make it more convenient, give you more options, and give you quicker access to solutions. All right, that's the ePart Trade commercial. Thank you. One of the great things about being part of ePart Trade, and then I was the editor of PRI Magazine for years, is that we have a vantage point where we're watching the whole industry at once. And our two speakers here, it's just remarkable to have them with us. Lake Speed is second generation in racing. His father was a great racer. And Lake, right away, when he came into the industry, just popped up here, there, and everywhere. And he had a very creative way of going forward and spreading his message. And now he's with an iconic company, Total Seal. So it's really neat to have Lake here doing this webinar with us for the first time. And then Jon Kaase is another person. When I finally became aware of Jon, and he's won his engines have won numerous Pro Stock championship titles in IHRA and NHRA. And his team has won the Masters Engine Builder Challenge many times. But the thing about Jon is that he takes time to share his insights and his experience with the industry. And I always think it's really valuable for not just veteran engine builders to hear from someone like Jon, but I love the idea of somebody new in the race engine business that's come on board. They have a lot of questions, kind of what to do and how to do it. And then there's somebody like Jon who's given kind of world famous presentations at the AETC at the PRI show, sharing his wisdom and insights. So with Lake and with Jon, we have real industry leaders, and we're proud to have them on board. And now I'll hand the program over to you, Lake. Take it away.
Thank you, Jon. I appreciate the very kind introduction. You know, like you said, it's kind of popped on the scene here in the aftermarket, but really, if you ask like a guy like Ron Shaver, who's a good friend of mine, I just kind of barged in the door. Yeah, you know, I was with my dad this past weekend. Dad's 72 years old. He's still go-kart racing. We went up and did some vintage go-kart racing. And, you know, really what's interesting is people know my dad, you know, as a NASCAR driver, or maybe some people know him as the only American to ever win the World Go-Karting Championship, which he beat a guy named Ayrton Senna in 1978 for that. And we're still really proud of Dad for doing that. But Dad's really an engine builder at heart. The old NASCAR shop where we built our own engines and built our own cars, we still have it. And the engine shop is still there. And in what used to be the Superflow dyno cell is now a go-kart engine dyno cell. And we still have the build rooms, and that's where you could probably find my dad probably right about now. He's probably over there working on a little 2-cycle motor. So he's got that mentality. So people look at me as a more of a second generation, you know, driver, and I'm not a very good driver. I can tell you for a fact this past weekend, I got my butt kicked. Yeah, it's a good dose of humble pie for me this past weekend, going racing up at Mark Dismore's track in Newcastle, Indiana. You know, I finished third, and I wasn't even close to the first two. And it's just a big dose of humble pies. Why I'm not a race car driver, you know, is that why I decided to get into on the race team side. Worked at Melling for a long time before going to work at Joe Gibbs Racing, and, you know, getting involved in the engine program there, you know, specifically being on the oil side. And that's, of course, my background is, you know, tribology, and using that as kind of a platform to really go after what has always been my real interest is engines. And that's where, you know, my experience at Driven and working with Joe Gibbs, that's what led me into contact with Mr. Kaase. It was a great customer and a great friend, and has helped us out tremendously. So very excited about being able to be here today with Jon and be able to answer questions from the crowd, which I already see we have a ton of them already. So with that, I'll kind of hand it over to Jon and let him maybe say a few words. And then I guess, Jon, whenever you're ready, we can kind of jump into some of these questions, I guess, because we got a bunch of them already.
Okay, well, good. You know, when you asked me to do this, I really didn't have any idea what we were going to be talking about. But I figured maybe since it had something to do with you being at Total Sale, we would get into some ring stuff. But I'm probably not one of the people that just spend endless hours with piston rings and seals and stuff like that. But we do pay attention to what's important. I think probably everybody listening knows my story, that I've been doing this for 52 years. And you know, the way I ended up where I'm really at, the big change for me was when I went to work for Don Nicholson in 1977, because it opened up a lot of doors, and I got to knowing a tremendous amount of people in the industry. So, you know, if it wasn't for that kind man that I learned a lot of stuff from, my life would have probably been a lot different. But we're here every day. You know, we've grown into a shop with 10 employees, and we're trying to survive this latest little hiccup in the road here in the economy. But all my guys have really banded together and really done good. And so I think we're pretty solid, and we're ready to go on and do whatever we do. You know, we've spread out a little bit, and we do different kinds of stuff than we used to. At one time, it was all drag racing. Today, there's a bunch of different things. There's a lot of marine stuff, and there's a couple other projects we're working on that aren't really done, that we've got NDA, so I can't really talk about them. But we've got a lot going on, so hopefully everything will work out, and other guys that are in this business will also stay in business.
Oh, of course, yeah. The industry needs everybody. You know, no one can be.
Yeah, we want competition.
Everything to everybody, right? And competition does make us better. There's no doubt about it. kind of like me get my butt kicked at go-kart racing this past weekend. I'm bound and determined to go get some more practice for next time I go, because I don't want to run third again.
Nope, you're right. Yep.
I will say this for everybody watching. If you want to know a little more of Jon's background and history, you should check out the Hidden Horsepower podcast. Jon was a guest on that podcast not long ago, and you're able to spend a lot more time on the podcast really telling about your background and your story and how you got into the industry. So for anybody who's interested in Jon's backstory, it is fascinating. Hidden Horsepower is the name of the podcast. Apple, iTunes, podcast, Spotify, SoundCloud, all that stuff. So it's all there if anybody's interested. So let's just go ahead and get into answering the questions. And we've got probably about 45 minutes left in this session. And I already see there's several questions on the side. So I'm trying to get over here and see. So forgive me if I'm not looking at the camera. I'm looking over here. I'm looking at the chat so I can try to answer some of these questions. Looks like the first one was from Michael. With gapless second rings, do you typically finish hone with a ball or a brush?
And you're asking me that?
Well, that was the question for both of us, Jon.
Yeah, I know. Well, we normally, we really just don't do a gapless second. Sometimes we'll do the top. And with that, it would probably, I would guess a gapless ring would be a steel ring. And, we normally just finish with the regular stones. We don't use too many diamonds here, but I've seen people use ball hones when they got done. And it can make it look like hell, but it works good. But we haven't really had the nerve to do that much. I've heard of people doing it. I've known people that did it, and they said it worked good, but we don't. But we do use the gapless top rings on some stuff, and I almost feel like on the ones that we used it on, the lower compression engines were the ones that liked them the most. But like 9-to-1 stuff or something, some kind of compression limit. But as far as the finish, we wouldn't do anything different on those than we would for the same kind of ring if it was just a regular flat ring. So if it was,
I agree that there's no reason to finish different for gapless versus not. Now, I will say our buddy Keith Jones, he has a very strong opinion regarding brushes versus balls. He's a big ball hone guy. He likes the idea of a ball hone. He likes reversing the rotation. Like if you go down one direction and then reverse it back the other direction. The theory being that
flips the balls.
The brush is only moving one way, so it bends the peaks over. Whereas if it's the reverse with the ball, it goes both ways, it'll break the peak off. That way you get that good plateau as opposed to that peak. I know our buddy, common friend, Ron Shaver, they run gapless seconds with their sprint car motors.
Wow.
And they've been doing it for a long time. They just kind of like a gapless second for the methanol motors. And with an aluminum block that's sleeved, they don't brush or ball. They just finish with stones like you. But with a iron block, like I say, a 360, they will come back and finish with a brush. They'll I think a 400 brush is what they finish with and then go. So hopefully that answers Michael's question. Again, Keith would say, don't use the brush, use a ball and finish that way.
Well, it could be they do the iron blocks because, on any aluminum block it's going to use a ductile sleeve, and those things are a lot different than an iron block would be as far as the material.
Yeah.
A little bit harder.
Yeah. So kind of a tangent to that question, I know you do a lot of things that are both, aluminum blocks where you're running the sleeves as well as iron blocks. Why don't you speak to that a little bit about, if you don't mind, about those differences in material and how you have to accommodate for that? Because I think that's more of a bigger difference, not so much the type of ring that you're using, is the
material. Yeah, well, it seems like on the ductile iron sleeves, which would be even an iron block, you might put a ductile iron sleeve in if you were going to repair it.
Right.
And yeah, they're a little bit tougher. You have to be more careful with, like, if you put a stone in there and you're going up and down with it, and all of a sudden it's gone 20 strokes or so, it's done cutting. You'd probably have to take it out and rub them together or do something, because they'll, if the stone isn't just perfect for what that material wanted, it won't stay. It'll burnish over or something. It'll do something bad.
Load up, yeah.
So we'll flip them around, and there's some stones that are real soft that won't. The kind that they go away as fast as you can feed it, with your hand, and they're not like that, but you have to have a whole box of them to do one block, but the ductile iron thing will probably get you in trouble quicker than a regular passenger car block would. If you hone it too long with the same grit stone, and you don't have the valleys just right and stuff in the finish, it'll kind of turn black on you, and it won't be very good when you crank it up. It'll be oiling and doing all kinds of bad things. You got to have fresh stones on it. That I guess what I'm saying is, if you take some of those stones and go up and down like 10 or 20 strokes, all of a sudden it'll start to turn darker and darker and darker. And you can almost hear it.
Okay.
It's got a swishing sound when it's cutting. And then all of a sudden that sound goes away, and it starts getting darker. That's not going to be a happy finish when you get done.
Yeah. Obviously, the different materials, when you have the harder, ductile material, it's going to be.
And we don't do too many passenger car type engines here anymore. The one that I'd almost welcome some input on is some of those blocks that are spray. It's like a spray iron on them. So the Coyote Fords are like that, and I think they do it under license from Nissan, and the Nissan GTR engines are that way. And it's not really Nickel. It's a spray-on plasma. I don't know what it is, but it's fairly good, and you can hone it with a stone. But we're not really quite up to speed on those like I'd like to be.
Well, that will jump us down to the fourth question. So we'll kind of jump out of order there real quick. Because Andy Rivard asks, with advances in cylinder coatings and liners such as Sumabore that have minimal crosshatch and grip on the surface finish, how does it affect ring rotation and ring life in a streetcar motor? I'm currently running a Porsche Flat 6 with Sumabore and some total seal rings as a trial. And I think that's kind of what you were just saying, is that, that those coatings like Sumabore, it's not Nickel. It's not Alusil. It's pretty new stuff. And while it's been used in very high levels of motorsports, Formula One, NASCAR, things like that, the rest of us, the real world, doesn't have a whole lot of experience with it in the real world.
I've never even seen it myself. So I'm learning along with everybody else here. But the Sumabore thing, I know that some of those start to get where they're pretty shiny, and they don't have much in the way of crosshatch and stuff. Sometimes the Nickel end up that way, but the Sumabore, I'm not really sure how you finish that.
So I don't know either. I mean, I know that you don't finish Sumabore the same way you finish even a compacted graphite block or Nickel or something like that. Essentially, you're going for a mirror type finish without crosshatch is what you're going for. And obviously I think the guys at like Rottler and Sonnen, they have the guidance, because they've obviously worked with the OEMs on what the right abrasives, the right coolants are in order to achieve that finish. One thing I can show, I brought my little handy dandy whiteboard. So if anybody that doesn't know what we're talking about in terms of Sumabore and what we're talking about a plasma spray bore. So normal crosshatch, angle, we can do like this. The cylinder bore is going to have peaks and valleys on it. And obviously with abrasive, you're going to cut it and you're going to leave those peaks and valleys, and the crosshatch, is going to, create those valleys that hold the oil as part of the whole process. The difference with Sumabore being a spray bore is, imagine as opposed to cutting it with an, or having a metal bore, you're actually spraying little bitty droplets. I'm trying to think of it. You probably can't see it. You're spraying small droplets of iron that are mixed with moly. And I know I'm drawing this way too small for anybody to possibly see it, but all those little droplets, if you imagine, say, a whole bunch of small ball bearings piled together, there's going to be gaps between those bearings, between those balls. And the idea of how you come in and finish that is you're going to come in and try to remove just the peaks of those. And by doing that, you expose the gaps in between. So whereas with a normal hone job on a conventional, iron or ductile iron bore, you've got these valleys from the abrasive that hold the oil. Now you have these gaps, and that's what those voids that hold it. So that's what creates that real difference in effect. So Andy, I know Andy pretty well. So we're actually looking forward to doing that project and seeing what actually comes out of that. So not sure if anybody else had any questions about Suma bore and what these mirror finishes are and why you would do that. But that's really the unique nature of that, is that you have that isotropic effect, because it's really a random pattern when you look at those bores to have those pockets that hold the oil. And as a tribologist and oil guy, this is my opportunity to say why this is important and how oil relates to ring seal. Is that my personal opinion and experience with oil as it relates to ring seal is oil is the gasket that basically goes between the cylinder wall and the piston ring, between the ring and the piston ring groove. You wouldn't take a head and bolt it onto a block and expect it to seal up without putting a head gasket on it, right? Oil's the same thing. It's going to act as the gasket. The surface tension of the oil is forming that gasket. And those valleys, those holes, that's what retains and holds the oil to allow it to seal up. That's one thing we learned at Gibbs. I'm not sure, John, if it's supposed to have been probably 2006, 2007, somewhere in there. We got into trying to do the super smooth, like mirror bore finish. And it didn't work worth a flip for us. Blow by went up. We would burn rings out. I mean, oh yeah, it was super smooth in the profilometer, but it wouldn't seal up well. And we had to change what we were doing with oil to try to make it work. And then we kind of had that light bulb moment one day. They're like, there's no valley to hold the oil. That's why we're struggling with. And then when we put some more valley to it and went back to the regular oil and worked perfect. Never looked back.
The stuff you're calling Suma bore, though, that's not what the Ford and the Nissan is it?
Well, they're all the same. I think Suma bore is a brand. It's not. Okay. They're all that spray bore where they're spraying.
But it's almost like iron. It's
yes.
It's a little bit like iron. It's nothing close to Nickel.
No, it's an iron and molybdenum mixture. Okay. Alloy.
Well, I thought all the cup cars were using that for a while, or were they?
Well, some of them are. So
it's on an iron block, it's better than the parent material?
Yes, it's very low friction. Now, the trick is it's very much like Nickel in that it's so hard, it doesn't really wear. So if you have bore distortion as the block seasons in, you're pretty much stuck with whatever you have. Okay. So the block has to be either pre-seasoned where it's already settled, or it's just that structurally made, good that it's not going to move around on you over time. I know some engines where the engine block itself is a stress member in the car, that can be a challenge. But yeah, a lot of the Cup guys that have figured out how to season the block and do all that, it works really well.
Well, the V6 Nissan, we don't do the whole engines, but there's a group here in Atlanta we do the heads and short blocks for. A lot of GTR, they're all the same. It's all GTR. I don't remember what they call them, 38 or something. But you know, they have that on the bores, and a lot of those blocks are used when we work on them, and we don't hone them or anything. You know, they just put new rings in them, put them together. They prefer we didn't hone them, although we probably could. But I've never seen one wear. I've never seen one that you could feel a ridge or anything, you know, at the top of the ring travel, or, you know, it's exceptional stuff if you
like
figure it out.
It is a brand. Sulzer Metco was the company that invented that, and you know, called it Suma bore, but I'm pretty sure it's the same process, the same type, that spray bore process is what Mercedes is using. BMW has it. Like I said, Nissan has it. The new Coyote Ford, they have it. So it's getting out there. So it's something we're all going to have to learn about.
Okay. Well, probably that's probably, it's even over my head a little bit, and we don't do much with it. So I'd say most people listening aren't real interested in it, because they're not going to get to that point, because we don't do anything with it here other than what comes in the Nissan.
All right.
Blake and John, I just have kind of a bigger question to throw at you, and we're getting questions, so thank you very much. Again, open up your chat option and send us a question. But just in general, is there some mistake that you see race engine builders making over and over again right now, or some race engine builders when it comes to piston rings? Is there anything where you like take this opportunity to say, just stop doing that and you won't have any more problems?
Probably too fine. You know, it seems like if you're a little bit on the coarse side, it'll forgive you still. If it's way too smooth, especially if it's a hard sleeve, it usually won't end well for you. You know, we have people sometimes they'll say, well, we just rebuilt this motor, and it might be just a local shop or something, but they'll call us and say, we rebuilt this motor, and it's oil, and it's you know, it's almost smoking, it's oily, and every time they'll say, oh, the intake manifold's leaking. You know, I mean, and I can tell you, if the manifold's leaking, it's going to idle fast. So that's probably not it. Okay. But, you know, and they take the manifold off, and there's oil running down where the gaskets go. And they say, well, the manifold's leaking. Well, you know, there's so much oil in that when it's idling and stuff, it's going up in the manifold. There's oil everywhere. But most of the time, it's the way it was honed. You know, it's not the rings. It's not the quality of the rings, you know, it's the way it was honed, and most of the time there's some problem there. And a lot of times it might be finished too fine, or it doesn't have the valleys like you need or something. But I know that if on any of that stuff, if you hone it with, like if it's been honed too far with a fine stone, like if you hone the last 5/1000ths out of it, or 3/1000ths out of it with a really fine stone, I'd say you'd be in big trouble.
Yeah,
you know,
there's
and
no
it'll look great, huh?
Yeah, there's no valley left by then, you know.
Yeah, and that you also see, that's Keith Jones' big thing too. Is the guys rebuild these motors, and after a couple of years, a lot of times they hone them a little bit, and they hone it a little bit more, and they never go back and start over. And you know, all of a sudden, all those valleys are gone because all you've done is hone it with a fine stone, and eventually it'll catch up to you and you'll be in trouble. You know, and the harder the sleeve is, I think the worse it is. You know, if it was a 283 block in some super stock car that was a 1964 or something, you know, Chevy, you might be able to get by with it because I think the iron's so soft that it might forgive you. But that's what we've seen, is this: if you do the finish wrong, and it's a little bit on the fine side, or it has no valleys, it might run oily, you know. And
other consideration about having the valley and being too smooth, I see quite a bit, and I'm not sure how much experience you have between gasoline and methanol, is that the methanol engines really need more valley. You know, there's just so much more fuel coming in. It's like a sprint car motor that's injected methanol. you have to have a good amount of valley to hold enough oil to offset the amount of fuel that's coming in. Otherwise, you'll just kill the rings and wash
Okay.
the board and everything's bad.
Okay. Then the other mistake that, and I'm still going off of John's question, and this is, we all do this, but it's a huge problem with rings and pistons. And that is, the motor sits for any length of time and you crank it up. If it doesn't have stainless headers on it, it sucks all that rust up into the rings that come out of the headers. And not too many people think about that, but I can guarantee you, if you have an engine that's sitting in the garage over the winter and it's been 6 months since you cranked it, and it's got mild steel headers on it, I absolutely guarantee you there'll be rust on the bottom of the throttle blades of the carburetor when you crank it up. It'll be that bad, because you know what it looks like when you grab an old header and go to put it on. You tap the collector on the floor. There's a big ring on the floor where all the rust came out of it. So. And not everybody, I mean, a lot of our dyno headers, they're not stainless because they're all homemade stuff we get here. And, we might have an FE header or something that we made ourselves that we dyno twice a year. When we get those things out, we have to tap on the floor and blow them out real good with air hose. There'll be so much rust coming out of it, you won't believe it. But whenever you crank an engine up, especially a new one, you don't want to beat on it, that thing 4,000 or 5,000 the instant it cranks, so it fires up to life, and all those pulses are going back and forth, and it'll vacuum all the rust all the way through the cylinders. It'll go up into the manifold, and it'll be bouncing around in there. And we can pretty well tell an engine when we look at it, when it's coming a used motor. We can tell if it had stainless headers or mild steel headers by looking at the bores. It's huge.
Great insight.
They'll be scratched up.
Yep.
And it'll eventually be gone, but the scratches won't be gone.
Right.
So I mean, and it's huge. You just wouldn't believe how huge it is, that rust that goes up in there. And people don't realize that when you crank one up and it's idle, and as long as it's got camshaft in it that's bigger than a street car, once it gets to certain degrees, it just vacuums everything out of the headers all the way through, all the way up to the carburetor when it's idling.
That's bad.
And then I just have one other kind of general question, and we have a lot of very knowledgeable people in the room with us, race engine builders. So when it comes to new developments in piston rings that maybe not everybody in our audience right now is aware of, and we're talking kind of the cutting edge, what should they know about piston rings right now, recent developments that maybe they're not aware of? Is something that comes to mind?
Well, the biggest thing I can think of, people typically think about Total Seal as a, gapless rings. And obviously that was, 52 years ago, Joe Moriarty Sr., that's how he founded the company. But today we make way more than gapless piston rings. The new gas-ported piston rings really are pretty special. Gas porting's not new. I think everybody that's probably on here right now is, understands what gas porting is and know that it's been around since the 70s. The earliest person I can get anybody to tell me did it first was Grumpy Jenkins, is what we keep hearing, is that Grumpy was doing it, in the early 70s. And those were vertical gas ports. And then over time, there's certain issues with having a vertical gas port, especially with gasoline and carbon buildup. And then people got on to doing lateral gas ports. And obviously lateral gas ports have been very common for a long time, been used in NASCAR and a lot of endurance racing engines. It really helps, provide better ring seal because you're using that gas pressure above the piston to assist the ring seal. You're getting it behind the ring to push it out. That allows a lower tension ring to seal more effectively when it needs to. So it holds that pressure. The idea of the gas ported ring is still fairly new. It's only a few years old. We've been doing it for some teams for a little while under NDAs where we couldn't talk about it. Now we're a little more open with it. And we did some testing here during the shutdown when we really couldn't do much of anything else. We really got to doing some head-to-head comparison where we were able to take gas-ported pistons non-gas ported pistons with the same ring combination. So we ran a gas ported piston with a diamond finish ring. Then we ran a non-gas ported piston with a diamond finish gas ported ring. So the only variable was the location of the gas port. And in doing that, we actually saw a pretty interesting phenomenon in terms of, normally as an engine increases in RPM, you'll see the blow by go up, or vacuum decrease over RPM. With this combination of moving the gas port to the ring, it was flat. Like it didn't care what RPM the engine was. The blow by just stayed constant and very steady. As a result, we saw an increase in peak horsepower and average horsepower over the operating range of the test due to that. So really, I'd say the most current innovation in ring technology really is just something that's kind of old. You're taking the idea of a gas port, but the new trick is just the location of the gas port. Get it out of the piston, put it into the ring, and that can give you a good opportunity to find a little more horsepower, and really doesn't cost you any extra money because you're just moving the location of the gas port.
Well, I'll add a little bit to that. It's just, and it took me a while to kind of think about this and figure it out. But as far as a gas ported ring goes, you might wonder, well, why? Why is it a big deal? Well, a passenger car, or there's a certain number there, of ring groove clearance. It's probably about 2,000ths or so. If you've got 2 or 3,000ths ring groove clearance, the gas ports don't make any difference at all, because it's already got the pressure going behind it. Right. Okay. And then when you close the ring groove clearance up to 1,000ths or less, then there's not enough room for the gas to get behind the ring. And I can tell you absolute for a fact, because if you've got like 1,000th groove clearance on a big engine and they forgot to gas port the pistons and nobody noticed till you put it together, it will be just fine until you go wide open with it. And the minute you go wide open, it'll try and blow the pan off it. There'll be so much blow by. So, that 1,000th of groove clearance or two would make all the difference. It would make 150 horse difference or so, because it loaded the ring, because the gas does get behind it. So back when Jenkins started doing that, and I think Lingenfelder, someone started working on it, they wanted the gas ports because they closed the ring groove clearance up. And, and this is one of the things that I just never understood until a few years ago at the AETC conference. Somebody mentioned, one of the piston guys from Weisco mentioned it, that you get ring flutter from a heavier ring or more groove clearance. So I'm thinking, well, that's just some number. That's just some name they came up with. What does that mean? Well, what it means is on the compression stroke, the ring's got weight to it. Okay, it's got inertia. Okay, when that thing changes direction, the compression stroke, the ring goes up enough that it uncovers the bottom of the land and it loses all its seal there. So if you've got 2 or 3,000ths ring groove clearance and you turn a real high RPM at the end of the RPM range, all of a sudden that ring weighs 40 pounds instead of an ounce or half an ounce, and it keeps going up when the piston starts going back down, and there goes a big blast of compression underneath it. And I only realized that like 2 years ago, but because I've heard that name before, but I didn't really I never thought about it. We know for a fact in our big engines, with a 4 3/4 stroke or 5 3/4 stroke, and 8,500 RPM, those things have a tremendous amount of weight to the parts when they're changing direction. So, and what we saw was with a round wire lock in the pinhole, the round wire lock would bounce up and down, it'd eventually come out. Well, the reason it bounced up and down was it had more weight to it than the spring load it had. And I think that lock weighed 32 pounds when it was changing direction, and it only had 5 pounds or something holding it in. So it would bounce and it would always go up because the wire lock groove at the bottom of the piston was all beat to death, not at the top. you know, so you know what it's doing. Well, the piston ring does the same thing, you know, so it's bouncing up and down in there. So the way to keep, the one thing that helps that is the narrower ring that doesn't weigh as much, you know. Okay, then the other thing that helps it is close groove clearance. But with close groove clearance, to kind of hold it in place and keep it happy there and behaving, you don't have the pressure to get behind it to push it out. So you know, one way or another, you have to get pressure behind it. You know, so it's a lateral gas port, top gas port, or that, you know, gas port in the ring. One of those three, it's got to have something. You know, so all that's a big deal, and it's the higher RPM you see, probably the bigger deal it is. But but that weight,
like I
and,
said,
and all that
higher the RPM, even like you said with the big motor stuff, and you're getting into these really big strokes, you're getting such high piston velocities.
Oh, it's more than any engine.
You have crazy piston velocity on an engine that isn't 10,000 RPM just because of the stroke.
Right. If you figure, I don't remember whether it's mean piston speed or whatever, but if you want to start figuring those speeds, there's really about nothing that you ever see in a race engine that's as high as those big engines that turn a lot of RPM. You know, a Formula One, a 500-inch pro stock, no, because of the stroke, I forget what it is, 8,300 feet per minute. I don't know. It's up there. But the force, when it's changing direction on all those little parts, it multiplies huge, and it also goes along with the ring, you know, and then and the gas pressure will seal it. And when the other thing that we see with the thinner rings is that on a thinner ring like 032.5 or maybe thinner, we don't really go much on the big engines. We're happy with that. But the thinner rings, it will conform to the bore with the gas pressure behind it, whether it's bent or not. You know, you can take a ring that you could take off the piston, put in the bore, and you look at it and put a light checking fixture in there, you know, with a light underneath it and a little disc, and you look around it, it's going to have probably 3 high spots, and the rest of it, you can see light everywhere, you know, and you say, man, when I fix this, it's going to be great. And you fix it, it makes the same power. It really doesn't seem to hurt it. And the only way that that's possible is the ring's so flexible that the gas pressure will seal it no matter what. It'll just push it out. And you know, we've had one time where we tried, I think I might have told you about this, but we had a customer that we had, you know, he always had vacuum trouble, a crankcase vacuum after a while. And so we thought, well, we'll try a little thicker ring, but the same ring, just 10,000 thicker. And we made it like 041 or 042 or something, but it was, you know, the same ring, you know, 135 maybe radial. And it left here and it was fine. And the first time they heard it, it stayed hurt, you know. it wouldn't, so that extra 10 thousandths of ring thickness wouldn't let the rings conform to the bore and get them back to being, you know, round and sealed up anymore, because it was more than the pressure behind it could do.
Yeah.
Okay.
Yeah,
but
sense.
So, you know, actually it's almost by accident. The flimsier rings were made for weight and for you know, ring drag maybe, and not much tension, but they had a quality that helped them, because they'll forgive you when you hurt one.
Oh, there's no doubt about that. You know,
Yes.
I'm sure I've told you in the work I did at Driven out at Ron Shaver's doing oil testing, we would do these, you know, 2-hour race simulations, and we could run, you know, 10 of them in a week. We'd, you know, one in the morning, one in the afternoon. You do 10 of them in a week, and you run and run and run. The best thing we ever did to make that engine consistent was go to 110 radial wall, 0.7 millimeter diamond finish ring. It made that engine, which wasn't very consistent before, and you were always having to kind of fight how much it was drifting, and everything. It just is a Swiss watch. It just runs and runs and runs, and it'll give you the same number any day of the week, anytime you want to run it. And you could move the tune here and there. It doesn't matter. It just became just impervious to all that. It was that was my first real experience with the thin ring, was that engine. And we got into it in kind of a weird way. We did it because we were looking, as I called Keith, I said, give me the hardest possible ring combination to break in on a wet sump motor. Because as a, trying to develop a break-in oil, I wanted something that was going to be really challenging.
That'd be a chrome ring, probably.
Well, he actually did even better than that. We did the titanium nitride, the tin paste, and we did that small ring with real tight groove clearance, like you said. We did all that stuff, and it was very sensitive. That if you didn't run enough load, which is one of the questions, is it imperative to break in an engine with load? That was a real key thing. That if you ran that ring with a diesel style oil, and let's say you ran it at like 5 to 10% load, forget it. It's oil. It wouldn't seat in. But if you ran it at like 15% load, and then ran it with a real break-in oil, with a low detergent break-in oil, seat right up, porch as dry as they can be, and ran great. So we found it ended up being right in terms of being a sensitive combination where you could discern not only your lube, but also your procedure of how you were breaking it in and make it work or make it not work. So it actually worked out pretty good. What other questions we got there?
Go ahead and grab some questions off the chat list. I know you're looking at the chat list as well. So just go ahead and pick through those, and we'll answer some questions here.
All right, let me flip down here and see what we have. Okay, so one guy asked, this is Hank Coburn, asked if the gas-ported ring would work well in a sprint car or boosted application. Yes, already got some guys running them in sprint car applications. And like John was saying, in a boosted application, the biggest key there is you got to check with your piston guy. If you're running a lot of vertical clearance in the groove already with the ring, then it doesn't really give you a lot of extra benefit because you already have that big gap, and it can allow the gas pressure to get behind it. But to control the ring better, you can run that tighter groove clearance. That engine at Shavers, we actually ran, John, we were running 7/10 vertical clearance. So 7/10 of a thousandth vertical clearance. I know some guys in the NASCAR stuff, they're down to 2 to 3/10 of a thousandth. Now, of course, they're preheating the water, preheating the oil. There's a lot of things that allow them to run that tight of clearance that you couldn't do normally. But if you do tighten that clearance up, then even on a boosted application, the gas port is a good idea to do. Let's just flip down here some more and see what else. This is any advantage running a thinner than a 16th top for an NA engine running less than 7,000 RPM. Yeah, that 100% from an 043 ring to that 0.7 millimeter ring on that small block Chevy, which is, 450 horsepower motor. That change from an 043 to a 0.7 was 22 horsepower. Going from 043 to 0.9 was worth around like 10 to 11. And then going from the 0.9 to the 0.7 diamond finish. So you kind of had two things going there. The diamond finishing helps, as well as going to the thinner. That extra combo gave it another 10 to 11. So it's a solid 20 to 22 horsepower peak, just going from an 043 to a 0.7. And that's from an 043 Molly style ring to a diamond finish ring. So you got a couple of variables there, not just the thinner ring, but also the smoother, flatter ring that can seals to the ring groove better. Because that's, like you're saying, it's all about getting the piston ring to seal to the groove. That's that highest pressure. That's where you got to get the good ring seal.
That bottom of that ring, the top ring, like you're talking with that finish, as long as the pistons are, and today's pistons are really finished good. you know, the equipment that they use, but that's probably the single most important sealing surface in the whole motor, more than the bore to the piston, is the
Oh, yeah.
bottom of the top ring and that top of that groove, that land that it sits on. If that thing's got any kind of, you know, wear to it or tape or whatever, or the ring's not real smooth on the bottom of it, it actually, it probably does two things. It doesn't load the ring as hard because some of that escapes from behind it, and then the combustion pressure won't. It'll lose. It just won't be as good.
Right. One of the questions over here is, how thin can the gas ported ring be? We can do down to 0.6 millimeter on the gas ported ring, and we can go as high as a 5/64. So that's one thing you can do, is that if you have a stock piston or a shelf style piston that doesn't have a lot of vertical clearance in it, and you want to upgrade it, you can do a gas ported ring on that and still be able to get some of that extra sealing benefit. That is not always a bad thing. Let's see what else. Oh, question or comment question from Damien about profilometers. Profilometers are a great tool to have. It's like you were saying earlier, John, about the different materials, the different stones, and how you hone. If you don't have a profilometer, you're guessing. You're
kind of guessing. But I would say though that we learned enough from using it that we don't use it always, because we kind of know that if we hone it to, you know, a certain size with this stone, and, you know, and then you do 2 strokes with this stone or whatever, and a couple more with this, usually it'll repeat fairly well if your process stays the same. But it's really interesting to see other stuff that comes in. You know, you get down below where the ring's ever touched,
right,
and start checking it out and seeing what somebody else did.
Yeah, exactly. That's that.
Yeah,
you'll know that's where it started.
Yeah, right. But it's a tool that you really do need, and I think it's made some heroes out of a lot of people, I would guess, that were probably making mistakes before.
Well, yeah, like I said, without having it, you don't really know what your process is yielding. It's a great inspection
Not
tool.
so much. You can't really look at it too much and tell, because you can't really see you can feel it with your fingernail or something, but you can't tell about the valleys too much. And the you know, of all the stuff, maybe the valleys to me might be the most important. But
let's me here reading here. What can be done to help finish the ring and piston to improve combustion sealing? Well, on the piston itself, if you can get by without having to anodize the ring lands, it's better. When you hard anodize the ring lands, it does make it less likely to seize, you know, to scuff, you know, micro weld in there. But the trick is when they do that, it makes it rougher. So now you get more blow by. We saw that in the NASCAR stuff, that, you know, the piston companies today can cut those ring grooves really smooth and really flat. And if you can get by without anodizing it, then you added the diamond finish ring, which is, you know, lapped very smooth top and bottom. Back to what you said, that's that most important area of seal. You can get a really good seal. But if you've got an anodized grooves, then you're going to lose a little bit. But I think there's some things that people are doing. They're getting better with some of the coatings and things to help that. Another thing too is the amount of rock in the piston to wall clearance. You know, the more piston to wall clearance, the more rock there's going to be, and that can affect how the ring can tilt and unload itself. I'm not sure, John, if you've messed with the line-to-line coating much. We've heard nothing but good things. Myself, I've not used it. I really want to on some of the two-stroke stuff me and Dad are doing, but I've heard really good things about the line-to-line and how it allows that piston to kind of fit itself so that it sits more stable in the bore.
I think we use it on some stuff. Um, it's not for everybody just because it adds to the expense. You
Right.
know, it's not cheap, but it is good. And we're kind of sneaking up on it. I mean, I've heard of people using 0 piston wall with it, but we don't have the nerve to do that. Maybe at some point, but a lot of people are using it with good luck. It's good company.
Yeah. A couple of questions I've seen here about ring tension. Now, I know there's a couple, some guys have the fish scale, and there's some things that people can do to, pull on the ring and measuring drag on the ring. One thing to note about the numbers you may achieve doing that versus, say, numbers that you would get from, say, Hastings or from us at Total Seal or somebody else in terms of what ring tension is, that as a piston ring manufacturer, we don't pull the ring to test tension. We actually have a gauge that sits in and actually measures the lateral tension in the bore, essentially. So that's a completely different reading than the friction reading you get from a pull. So just know that that's apples and oranges. Those numbers don't add up. I know one thing we hear a lot, and I'm not sure how much nitrous stuff you do, John, but when you get into the nitrous stuff, you better have a lot of ring tension because you need really good oil control. Otherwise, bad things happen quickly.
Yeah, we actually don't. We do some boosted things, different kinds of engines, and those are more in the marine. But we've kind of resisted the nitrous pro mod type stuff, and we don't really do any of it.
Yeah.
I'm not a big fan of pressure vessels. Really.
Well, if you think about it, when you're spraying nitrous in an engine, be it a gasoline motor or even a methanol EA5 combination, you essentially have two different fuels. You have a liquid fuel and a gaseous fuel. That it's gasoline. It makes gasoline pretty interesting compared to, say, when you run nitrous with it. Is gasoline is a blend of different length hydrocarbons. So we talk about octane. Octane is a 8 carbon molecule, but gasoline is a blend. It will have some shorter and some longer, and that's why there's a distillation curve of gasoline, that it all doesn't evaporate at the exact same temperature. We all think about light ends. You can smell that, but you're smelling fuel evaporate, but you still see fuel. Well, why is that? Well, it's because it's a blend. Whereas, say, methanol, it's a single molecule. So they behave differently. There's not a distillation curve for methanol. It's a distillation temperature. There's no evaporation, 100% evaporation. And when you're talking about nitrous, again, single molecule, single evaporation point. Those are some variables to throw in there when you're thinking about tuning and how they work, and that's just one of those. I'm again chemistry guy. I love it. It's fun and interesting to me.
Okay, Lake and John, we kind of wanted to devote an hour to this and then wrap it up, and we could probably go for days talking about this. But I want to be respectful of your time and everybody's time in the audience. So I'd like to kind of wrap this up. And then, Lake, if people have additional questions, we didn't answer them all, could they just contact you with questions?
Oh, yeah. I mean, feel free to contact us. We've got 3 guys sitting there in Phoenix, Arizona right now that have combined between those 3 almost 100 years of racing and engine building, piston ring experience. Bobby, Kevin, and Keith Jones are they're veterans of this. They've been doing this. They've forgotten more about piston rings than I'll probably ever know. So I would suggest anybody, if you're working on an application, you've got some detailed questions, which I know we didn't get to everybody's questions, feel free to pick up the phone, call those guys, 623-587-7400. And if you lay out your details, they can help you out pretty good. Or you can feel free, send me an email. My email is lake@totalseal.com. I'm happy to help as well. We want to be a resource to the industry. you know, just like what we were with the oil, if there's an application and we don't have the right answer for it, we'll tell you that. We don't care. I mean, it's not like we're just trying to sell you these kind of piston rings only. The idea is that if you can define the needs of the application and then bring the right products, the right process to the application, you're going to get the results you're after. And that makes everybody happy and keeps people in the industry. You know, just a real quick side note, at the karting races past weekend, you know, my dad was talking to a guy, and these old carts have centrifugal clutches in them. And in the old days, those clutches were just the bane of everyone's existence. You could get your carburetor tuned up, you get everything right, but that clutch was just going to fight you and fight you and fight you. And without fail, the clutch was going to lay down when you're leading the race. You're going to pass the guy is when the clutch would lay down. And one of the first things I did when I came back to doing some racing with my dad was, I'm like, wait, there's oil in that clutch. By God, there's something, we can make this better. And we worked on developed an oil we actually sell through ATI to make those clutches work. And the guys were like, man, I wish we had this back in the 70s and 80s. More people would have stayed in karting if they hadn't fought the clutch. That problem is what drove people away into something else. And that's that same lesson here is we don't want people not tuning and messing with engines. We want everybody that's got any itch for horsepower, get in that engine, go to the junkyard, buy an LS motor, buy you something and put a turbo on it, go crazy, have fun, make some power. But let's help people overcome the common obstacles. That way they don't get frustrated, throw their hands up and say, I'm done, screw this, I'm gonna go do something else. You know, we want people racing, we want people making horsepower and having fun, and we're here to help.
Very good. And John, before we leave, anything you want to add?
Well, I'm just happy. This is my first. You know, I'm about 2 generations behind on the technology here. So we were actually lucky to get the computer up and get it to work. And this is kind of like we were talking yesterday. It's like going back to the Jetsons cartoons we watched when we were kids. You know, they had all the TV screens where the people were talking to each other. You know, we're almost to the point where that cartoon is today. You know, but I'm just glad that we could do this from our confines of our shop and not have to go somewhere.
Yeah, modern technology is pretty neat in some ways.
Yeah.
Well, this has been great. Thank you for your time. Thank you for so frankly sharing your expertise, John. Thank you, Link, for helping us organize all this and spread the message that we were going to do this. We got a good packed house, so that was great. Thank you all for joining us. We'll send you an email with a link to the video if you want to share it with anybody. And we'll give you a password too, so you have easy access to ePartrade. All right. So thank you all very much. This has been wonderful, and we'll do it again.
Thanks to everybody for attending. We appreciate it.
All right. See y'all.
All right.
Bye.